Programming a Siemens logo PLC as a dyeing machine temperature controller. The project overview. This temperature control system is designed using a Siemens logo PLC, and it has two modes of operation. 1. Auto. 2. Manual. In auto mode, the system can control the temperature of a typical dyeing machine based on a predefined time temperature table. In manual mode, an operator is allowed to turn on or off any of two heat or cold sources of energy relays independently. The system hardware. Figure 1 displays the hardware of the controller, which is consisted of the following parts. 1. The logo PLC. 2. The first I/O expansion module. 3. The second I/O expansion module. 4. The logo TDHMI module. 5. The PT100 temperature sensor. 6. UST200 universal signal transmitter. 7. The operator's panel. The system functionality. The system has two modes of operation. 1. Auto. 2. Manual. In auto mode, tapping on F1 button, the system controls the temperature based on a predefined time temperature table, see figure 2, which is integrated into its PLC control software program. Tapping on F2 button, the system keeps the temperature of the container at a constant temperature of 80 degrees Celsius, see figure 3. In manual mode, an operator can turn on or off each of the hot or cold relay independently and view the PV temperature value on the HMI device.
Today I would like to talk about a controller, a temperature controller which is built around Siemens logo PLC. As you see, this temperature controller has a panel by which we can stop the system, and also we can change the status to put it in auto or manual mode. And when it is on manual mode, we can turn either hot water or cold water valve on and off. When it is on manual mode, we can turn the switch down to turn on cold water, or we can switch it to hot water valve. In this case, hot water valve is on, and the temperature is going to go up continuously. As you see, this system has consisted of a logo, an expansion module, a transmitter, and also logo TD, which is displaying the PV and SV temperatures. I have also connected the sensor, PT100 sensor, to the transmitter, to the input of the transmitter, and some water here, and also in the bottom there is a small electrical oven, and by which I can turn the temperature of water, increase the temperature. Simply, to start the process, we can push the start button. The light inside the button turns on. That means right now system has started, and backlight is on. And in this case, system is waiting for the operator to either push function 1 or function 2. Function 1 is a process that heats up the temperature of the container by some steps on the curve, and during that, from step to step, it increase the temperature. Function 2 is a constant temperature. It takes about 2 hours, and it tries to keep the temperature of the container, water in the container, to 80 degrees centigrade. When you push F1, as you see right now, it says that temperature sensor is sending to the system is 21, and but set temperature, set value is curve temperature is 25. So because the temperature on the sensor is lower than SV, so it turns on the hot water valve right now, and this LED indicator, red one, shows that the heater is turned on right now. As time passes, the temperature is gonna go up, and then controller is gonna follow whatever the time temperature curve is saying. And of course, all this data is included in the program of the ladder logic program, which is downloaded to this logo. On the display, logo TD, you see that the time is about 1 minute pass, and we are on auto mode, and of course F1 function. To come out of this process, we can push stop the process button, and then to return on the system, start the system, and then here again this time push F2 function, and this way you're gonna see that system is in auto but F2 mode, and the curve says that it has to be 80 degree, but the temperature on the sensor is reported as 22 centigrade degree, and so the outside the hot water valve is turned on, and system is going to keep the temperature around 80 degree in little by little. And when we, as I said before, by putting the hammer switch down, we can go to auto, to manual mode, and in this case, right now, cold water valve is turned on. And because the contactor, the relays, this is a relay module, so you hear the noise coming from on and off of the relay. And when I put the hammer switch up, so the hot water valve is turned on. All this information that I talked about comes in the book and an ebook, so please to receive some more information about how the program is developed, go to the website and check it out. Thanks for watching my video.
This title, which is prepared in 2 chapters and 65 pages, details the generation of code for the Logo PLC to control a temperature process in general. All main control program solutions are prepared in LDA language. In this manual is written for Siemens Logo PLC using Logo Soft Comfort software, but the ideas and program layouts are universal to any PLC. In addition, the schematic of all the hardware used in this project is provided and are fully explained. All control software, related to the project, comes with the purchase of the project ebook, and you will not need to develop any extra PLC control program for any part of the project. Chapter 1 explains the hardware part of the temperature controller, consisted of the schematic diagrams of how to input-output devices can be hardwired to a Logo PLC hardwired, or to the Logo expansion unit model, DM1624R. Chapter 2 explains the Logo control software program, how does the PLC calculates SV value, displaying texts on the Logo TDHMI device, calculation of the slope of a straight line, and the formula, and finally a description of some special functions related to Logo PLC.
Thank you for watching this video. If you want to see more videos like this, then click subscribe and like buttons below, and share it with your friends. Also, tell us your opinion on this video in the comment section below.